What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Security Plus 701 certification exam. So let's get into it. In this video, you are going to learn about more mitigation techniques such as patching, encryption, monitoring, least privilege, configuration enforcement, decommissioning, and various hardening techniques. All right, so let's talk about patching. So patching, this refers to updating or fixing a system, including software applications, drivers, and operating systems by applying patches or updates. And these updates often contain fixes for known security vulnerabilities, improvements to performance, or new features. So for example, if a vulnerability is discovered in the enterprise's web server software, a patch can be applied to correct the issue, thereby closing the potential entry point for attackers. And regular patching, this is essential to maintaining the security of systems and protecting against known threats, as outdated systems can be more easily exploited. And patching, this is a universal cybersecurity practice, but industries tend to approach the process differently based on the impacts in their environment. And here are some examples of how different industries might approach patching and some special challenges they encounter when balancing security with meeting operational demands. So the first one is the healthcare industry. So the importance is because personal health information is highly sensitive, regular patching in healthcare is vital to protect patient confidentiality. And the challenges are patching medical devices and legacy systems without disrupting patient care services. This can be complex. And the solutions are implementing a patch management policy that includes testing of patches in isolated environments before deployment can reduce potential risks to critical systems. Next, we have the financial services industry. So the importance of this is financial institutions. They handle large volumes of sensitive data related to banking details and finances. So timely patches is essential to protect against fraud and data breaches. The challenges: compliance with regulatory requirements such as PCI DSS. This adds complexity to the patching process. And a solution is a well-structured patch management process that is aligned with regulatory requirements. This helps ensure consistent security while maintaining compliance. Another example is the manufacturing industry, and the importance here is in manufacturing, securing industrial control systems and the Internet of Things devices is crucial. So patching helps protect these systems against vulnerabilities that could lead to production disruptions. The challenges could be downtime for patching. This can affect production schedules, and some embedded systems may be difficult to update. And some solutions could be scheduled patching during non-peak hours and robust testing prior to deployment. This can mitigate potential disruptions. Next, we have the education sector. So the importance here is educational institutions. They manage a diverse array of devices and user roles. So patching is key to protecting student and staff information. Some of the challenges: the wide variety of systems and decentralized nature of some educational networks. This can complicate patch management. And some of the solutions: centralized patch management solutions that are tailored to the unique environment of an educational institution. This can streamline the process and ensure timely updates. And then we have the government and public sector. So the importance here is patching in government systems is critical for national security and the protection of citizens' data. The challenges: bureaucratic processes are complex, interconnected systems, they can slow down the patching process. And some solutions: implementing clear guidelines, automating patch deployment where possible, and establishing a dedicated security team. This can enhance the efficiency and effectiveness of patching. All right, next let's talk about encryption. So encryption, this is the process of converting information into a coded form, making it unreadable without the correct decryption key or algorithm. It protects the confidentiality and integrity of data, both in transit and at rest. So for instance, an enterprise might encrypt sensitive customer data stored in a database, or for use with secure socket layer, transport layer encryption for secure communication over the internet. And encrypting this data, this prevents unauthorized parties from accessing or altering it, ensuring that only those with the proper credentials can view or modify the information. Next, we have what is called monitoring. So this involves continuous observation and analysis of system activities and behaviors to detect and respond to potential security incidents. It can include monitoring network traffic, user activities, system performance, and logs. So for example, the enterprise's security information and event management system might alert administrators if suspicious login patterns are detected, such as numerous failed login attempts from a foreign IP address. So monitoring this provides real-time insights into what's happening within the systems and networks, enabling prompt detection of suspicious or anomalous activity and facilitating swift response to mitigate potential threats. All right, next we have what is called least privilege. So the principle of least privilege, this dictates that individuals or systems should have only the minimum levels of access or permissions needed to accomplish their tasks. And this minimizes the potential damage from accidental mishaps or intentional malicious activities. So for example, in a hospital setting, nurses might have access to patient medical records, but not to the financial information of the hospital. Similarly, an IT technician might have the right to update system software, but not to have access to confidential HR records. So implementing the least privilege principle effectively limits the risk of unauthorized access and minimizes the potential impact of compromised credentials. All right, next let's talk about configuration enforcement. And this involves the standardized and consistent application of system settings, policies, and controls across an organization's networks and devices. It ensures that all elements of the IT environment adhere to defined security policies and best practices, thereby reducing vulnerabilities. So for example, an enterprise might enforce strong password policies across all user accounts, requiring a mix of characters and regular password changes. This configuration enforcement can be implemented through group policy or other centralized management tools. And by standardizing and enforcing these security configurations, the organization ensures that all users comply with the best practices, reducing the risk of weak passwords that attackers could exploit. All right, next let's talk about decommissioning. And this refers to the planned process of taking hardware, software, or subsystems out of active service, and it is often essential to the lifecycle management as systems in their usable life or become obsolete. So for example, consider a server hosting an application that is no longer needed. Simply unplugging the server without proper decommissioning may leave residual data, configurations, or connections that could be exploited later. An appropriate decommissioning process includes carefully reviewing the system, removing sensitive data, uninstalling software, and ensuring that network connections are terminated. And in some cases, physical destruction of the hardware may be required. And by following a structured decommissioning process, an organization mitigates potential security risk associated with obsolete or unused systems, and the system is safely retired without leaving lingering vulnerabilities that malicious actors might exploit. All right, next let's talk about hardening techniques. So one essential strategy to safeguard enterprise systems and data is the hardening process. Hardening techniques, they consist of systematic measures taken to minimize the attack surface of systems and reduce vulnerabilities. By eliminating unnecessary functions, an organization can make it considerably more challenging for potential intruders to exploit weaknesses. And these practices are not limited to any particular type of hardware or software. They can be applied to servers, workstations, network devices, applications, and much more. So the following, we're going to dive into specific hardening techniques, each aimed at strengthening an organization's security posture and fortifying its defenses against potential threats. All right, so the first one we're going to talk about is encryption. So as mentioned earlier, encryption, this is the process of transforming data into a coded form, making it unreadable without the correct decryption key. So encryption, this can be used to harden and protect data stored on disks or specific files and folders and data transmitted over networks. Encryption, this ensures that the data remains unintelligible without the proper keys, even if an unauthorized person gains access to it. Next, we have the installation of endpoint protection. So installation of endpoint protection, this refers to implementation of security solutions designed to secure endpoints or user devices such as computers, smartphones, and tablets. So by installing endpoint protection software, an organization can protect against malware, phishing attacks, and other threats that target user devices. And these solutions include antivirus, anti-malware, and other security features tailored to defend the individual endpoints. Next, Next, we have a host-based firewall. So a host-based firewall, this is a software firewall installed on individual devices. Unlike a network firewall that protects an entire network, a host-based firewall controls incoming and outgoing traffic for the specific host on which it is installed. This type of firewall can be configured to allow or deny traffic based on rules set by the administrator, providing an additional layer of protection for individual systems. Next, we have what is called a host-based intrusion prevention system, or HIPS. So a host-based intrusion prevention system, this provides real-time protection against known and unknown threats by monitoring the behavior of the host system. A HIPS can block or alert administrators to potential attacks if suspicious activity is detected. So for example, if an application tries to modify a critical system file, the HIPS might block the action and notify the security team. The next hardening technique is disabling ports and protocols. So specific ports and protocols on systems may be unnecessary for an organization's operations and can pose security risk if they are left open. Identifying and disabling unused or unnecessary ports and protocols, this reduces the attack surface, limiting potential entry points for attackers. However, it is vital to approach this task with caution and awareness. A thorough examination of all open ports must be conducted before they are closed. Security engineers typically build a list of ports and protocols to exclude in much the same way the IT team assesses, researches, and builds an approved list. Closing ports without understanding their functions, this can severely impact services that use the ports, potentially causing system outages. And with each port or service, an organization can implement a tailored approach to port and protocol management, strengthening their defense against potential breaches without compromising essential functionalities. The next technique is default password changes. So many devices and systems have default usernames and passwords, which are often well known and easily exploited. Default username and passwords are credentials automatically installed or programmed into a device or software system. So changing default credentials to solid and unique usernames and passwords is a simple yet effective hardening technique that prevents unauthorized access through commonly exploited credentials. And then finally, we have the removal of unnecessary software. So unnecessary software includes programs on the system that are no longer in use or that were replaced by an updated design. You may hear this also referred to as quote unquote tech debt if there is an obscure reason to keep the software on the system. Unnecessary software can introduce vulnerabilities, especially if it needs to be updated or better maintained. An organization can reduce potential weak points that attackers might exploit by identifying and removing software that is not required for business operations. All right, so that was my video where you learned about more mitigation techniques such as patching, encryption, monitoring, least privilege, configuration enforcement, decommissioning, and various hardening techniques.